Hello everyone, this is a video on vertical projectile. This way, vertical means in and up and down direction. To project is to shoot. So in this topic, we'll be talking about things that are thrown up and down in a vertical direction. We're going to look at an example. Then I'm going to use this example to explain this concept to you. Okay, when you get a question like this, you need to read it at least 3 times. When you read it the first time, you just want to know what the story is about. It says a stone is thrown vertically up with an initial velocity of 25 meters per second from the top of the building. When it falls back, it misses the top roof of the building and falls to the ground at the foot of the building. Okay, let's read again. Maybe try to make a drawing to understand before we even look at the questions. It says a stone is thrown vertically up with an initial velocity of 25 meters per second from the top roof of the building. So it means we have a building and we have somebody on the building and throws the stone up, right? Now, the velocity of the stone is 25 meters per second from the top of the building. When it falls down, it goes up, stops, and then comes down. When it comes down, instead of falling on top of the building, it misses the building and falls on the floor of the building. Okay, this is what the story is about. Now, with vertical projectiles and with most sections of science, you need to choose direction. In science, direction is either negative or positive, and the negative is direction, is not the magnitude. It doesn't mean when it's negative 25 it's smaller than 10. No, the negative just tells you the direction, and also it tells you the direction according to what you have chosen. So in this question, I'm gonna choose positive to be up. Anything that's going up is gonna be positive. Now, another important thing is that you can't switch and change in a question. This is 1.1, 1.2, 1.3. All these questions you have chosen up as positive. You can't go 1.1 up positive, 1.2 down positive. No. You choose once and you finish the whole question. Another important thing is to now write what you are given. The statement is giving you some things, then you write what you are given. The first thing that we are given the initial velocity. They said the initial velocity is velocity with I. Initial velocity is 25 meters per second, 25 meters per second, and it's thrown up. So that's why it's positive. If it was thrown down, it would be negative because we chose positive, up as positive. Everything that's going up will be positive, right? The next thing that you're always given in this question, when we are throwing things up and down, there's gravitational acceleration that's acting on that object. The gravitational acceleration, the symbol is G, and it's always going down. It's pulling down. So because in this question we chose up as negative, our gravitational acceleration will be negative, and it is 9.8 meters per second squared. So that's why it's important that you choose the direction correctly. And then with this question, you always need 3 things to get the 4th one. Now, the other thing that we have height. It says we must calculate the maximum height of the stone above the rooftop. You remember they said this person threw it up. And then on the maximum height, when you throw something up, on its highest point, it's going to stop before it starts going down. So it means we have our final velocity. Our final velocity is 0 meters per second. Because when we are throwing something up, it goes up, 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 up. On its highest point, it stops. What are we supposed to calculate? The maximum height of the stone above the rooftop. So I want the distance from where he threw the stone up. So what I want is displacement. This is what I want. So you take your formula sheet and then you look at the formula that has the other things, and you can find this one. Then, very important, copy the formula exactly as it's written in the formula sheet. Do not fiddle with the formula. You copy it, you substitute, then you do your maths. When your maths is wrong, you lose 1 mark. But when you fiddle with the formula before, you lose all marks if you make a mistake. Our correct formula is this one. Final velocity squared is equal to initial velocity squared plus 2a is for acceleration in this question, because we're talking about vertical projectiles, is gravitational acceleration and then change in displacement. So let's substitute the values, which will be 0 squared 25 squared plus 2 minus 9.8 and change in displacement. 0 squared is 0. The square root of 25 is 625. This will be minus 9.8 times 2 is negative 19.6 change in displacement. We're going to take this to the other side. It will be negative 19.6 change in displacement. And then we divide by negative 19.6 both sides. And then we get that our displacement is equals to, let's divide, 625 divided by 19.8, 31.5, negative 19.6 divided by negative 19.6 here. Our answer will be 31. Our answers are rounded off to 2 decimal places, so it's 89, and displacement is measured in meters. So this is how we do the first one. Displacement is a vector. It's the distance that's a scalar. This is a vector. So it means it has direction. It has magnitude and direction. Our answer was positive. So it means it's 31.89 meters going up from where they've started. Okay, the second question, calculate how long it took the stone to reach its maximum height. They are actually asking us, as through the stone it went up, how long did it take? So the initial velocity, the gravitational acceleration is still the same, and the final velocity, because they say it went up, so the final velocity is where it stopped there at the top. So the formula that we use, let's find our formula sheet and check which formula I'm going to use. We're going to use the formula final velocity. This is number 2. Final velocity is equals to initial velocity plus acceleration change in time. Please, very important, leave the formula as it is. Substitute in the formula. So we have 0, and then it's 25 plus negative 9.8 and change in time. So it's basically the same like the first one, 9.8 change in t, then divide both sides by 9.8, divide both sides by negative 9.8, and your change in time, you divide that, you calculate, and then you get that it's 2.55 seconds, right? Another thing that's important, in a science paper, it's not a maths paper. They don't give you marks for the lot of maths that you're doing. So if you're doing too many math steps, you're not getting marks for that. You get a mark for the formula, you get a mark for substituting correctly in the formula, and then the other mark is for calculating the correct thing. So all the maths that's in the way, you don't get marks for. Let's look at the next question. Okay, the third question says, calculate the velocity of the stone after 7 seconds. Okay, so that's our number 3. So we have initial velocity, it has not changed. The gravitational acceleration has not changed. And then now we want the final velocity after 7. So it means that they've given us change in time, that is 7 seconds. So we have that. Now we want the final velocity. So we're going to use this formula that we used in question 2. Then we substitute. Our initial velocity is 25, negative 9.8, then multiplied by 7. Then our answer is negative 43.6 meters per second. What does negative mean? You remember we chose going up as positive. So it means our final velocity after 7 seconds, that stone will have a velocity of 43.6 meters per second, but it will be going down. That negative is telling us that it's going down because we chose going up as positive. You have to write that in your answer. Let's look at the next question. Okay, the last question. Calculate the height of the building if it takes the stone 10 seconds to reach the ground after being thrown up. So our time, change in time, they're saying it's 10 seconds. Now the stone was initially thrown up with the initial velocity of 25 meters per second. We chose going up as positive, so our gravitational acceleration is negative 9.8 meters per second. So we were asked this distance. Displacement is the distance between from where you have started and where you have ended. So the displacement here, it was thrown up and then it went back. When it comes here, it is 0 because there's no distance from where we started. We started here, went up and went back. So when we calculate, we'll only get this one because we didn't go back. It's very important to know the difference between distance and displacement. Distance is where you have traveled. It's a scalar quantity. Displacement is a vector quantity. It's the space between where you have started and where you have ended. You have to check where I have started, where you have ended. So in this question, this part will be 0 displacement. And then when we calculate, we'll only get this part. And this part will be the height of the building. Let's look at the formula that we are required to calculate. We want displacement, so this is what we want. The formula that will be suitable for this, when you look at your formula sheet, is change in displacement is equals to initial velocity, change in time, plus half acceleration, change in time squared. Very important, stick to the formula, substituting the formula. If you write the formula and you don't substitute any value, you don't get marks. If you write the formula and substitute wrong values, you get marks for substituting. You have to substitute in the formula. Don't just write the formula and think you'll get 1 mark. You won't. You have to substitute. So in this question, you're not going to substitute wrong formula values because we have the right ones. Our initial velocity is 25 meters per second. Our time is 10 seconds. And then the formula comes with a half. And then our gravitational acceleration is 9.8 and our time is 10 squared. So you remember, the more maths you do, no marks. So just take your calculator and punch everything here and then get your answer. Your answer will be negative 240 meters. So what does negative mean? It means down. So it means from there going down is 240 meters. So the distance of the building is 240 meters. So because it's displacement, the 240, it means it's from there to there. So you don't have to say downwards. So it's 240 meters. The building is 240 meters long. This is the end of our lesson. I just hope you practice this section and then think about what you are doing. It's not that hard. Thank you for watching.